Right, greetings to all. Welcome. Thank you for taking the time out of your schedule to join in for the MeshWorks 2020 session. And we're going to talk about MeshWorks application for farm and construction equipments. I hope my audio is coming out very clear. Abdul or Ilan, can you confirm?
Yes, Karthik. Clear.
All right, thank you. Thank you so much. Yeah. So it is indeed a privilege. I hope as things are getting back to normal at many parts of the geographies where we are in, I think we are slowly getting back to work, and it's a good sign. And it's we are quite optimistic about that, and we also look forward to have a lot more activity going on, and we'll be able to bring in a lot more new messages from our side to you post COVID situation. Now, what we have today as an agenda for discussion is as follows. We are going to briefly talk about MeshWorks 2020 and in the perspective that how it is relevant to product development. That is how we are going to look at MeshWorks as an engineering platform and its relevance to product development. We're also going to take it one step forward and see how it is relevant in the context of farm and construction equipments. And we're also having set of demonstrations today from my colleague Abdul, and he's going to exactly take certain scenarios that we face as part of our work in farm and construction equipment design and engineering work, and see how MeshWorks provides you that needed tool set and acceleration. And subsequently, after the demonstrations, we are going to see certain takeaway messages as to how we can remember MeshWorks as in terms of how it really would help us transform the way we are doing stuff as far as design and engineering is concerned with farm and construction equipments. Having said that, we will go into the next slide, which will give you an idea about what is MeshWorks as an engineering platform. That is, or as a pre and post, how is it going to facilitate a lot of our activities from farm and construction equipment sector? The first and foremost important thing, MeshWorks 2020 is not a new platform. It is a well-established platform, close to 2 decades of experience. We have a lot of leadership in the area of math data morphing, especially the CAE data, CFD data, CAD data. We have a lot of leadership in the area of morphing technology. And as part of that, as a next step, I would say, to morphing, parameterization of models. So we are one of the leaders in CAE model parameterization. And when we say parameterization, we are not limited to shape, size, material, but we extend it to the whole lot new level of even having certain design features like ribs, or the weight reduction holes, or bulkheads, or part extensions and contractions, or topology related parameters. So we bring in a whole library of tool sets on parameterization. That's a great leadership area for MeshWorks 2020. And both of these enable design optimization. And we really see that this design optimization is very efficient for your farm equipment sector, where we are trying to reduce the dead weight of the machine without compromising either the payload or the lifting capacity. So MeshWorks' morphing and parameterization technology is right up the alley as far as design optimization of farm and construction equipment is concerned. On the left-hand side of the slide, you will see there are certain other new tool sets that we have brought in MeshWorks 2020, which are ConceptWorks. This comes very handy when we are looking at way upfront in our product development cycle, where we do a lot of generative design related studies, or where we try to conceptualize our construction equipment cabin or the ropes cabin for our tractors. So when we try to conceptualize that, ConceptWorks can come in handy to create structural concepts, or even for that matter, sometimes some of the chassis components that we want to optimize. And we use a lot of generative design and topology kind of optimization techniques to configure our structural layout, which is mass efficient. So even at that point, that these topology studies, generative design inputs can all become inputs, and we can generate a workable, manufacturable concept out of that, using MeshWorks. So that's a very important ingredient that we are going to showcase today and how it really helps. And regular pre and post processing is also a very good addition. State-of-the-art tetra meshers, mid-plane meshers, as well as hexa meshing tools are available in MeshWorks. And the most important thing that you should note from this perspective is the comprehensive welding tool set. So the seam welding tool set with heat affected zone, without heat affected zone, running in the direct GUI mode, as well as running in the batch mode, brings in a lot of acceleration to the way we are creating finite element model today. So that's an important piece. And process automation, many a times if we are assembling a clutch pack, for example, for our transmission casing in a farm and a construction equipment, we want to have certain level of process automation to that. And MeshWorks brings in the process automation to assemble CAE models, right from the CAD cleanup all the way till completely assembled models with connections and contacts. And this process automation is created without having us to be experts in TCL, TK, or Python, or any of those programming. So this process automation is more like walk the talk kind of a scenario. So you record what you are doing and then play it back. So as simple as that. So this is what is our set of important things that we wanted to bring up as MeshWorks 2020. And in the next slide, you will see how MeshWorks 2020 tool sets stack up in terms of the product development cycle. If you happen to look at from the left side of the slide, you will see the concept stage, detailed design and engineering stage, verification and validation stage, maintenance or VAVE kind of engineering activity stage. These are traditionally goes on in our product development process, and we do this almost throughout the product life cycle, sometimes refreshes, newer designs. So this keeps happening. In an automotive context, if you look at it, our morphing and parameterization technology, design optimization technology to support DOE-based model creation, all of those tool sets are very useful at the concept stage, where we are able to examine a lot of concepts and come up with a very workable concept which meets a lot of our requirements and objectives and bring it to the detailed design stage. Which means if you are looking at front loading a lot of your engineering work in the concept phase, MeshWorks is morphing, parameterization, and design optimization tools are the clear technology stack or the engineering stack that you need to accelerate the work at that situation. Now, coming into the detailed design phase, MeshWorks is pre-processing tools, especially as I pointed out, the shell meshing tools, the mid-plane plastic meshing tools, the hexa meshing tools, the tetra meshing tools. Along with that, the model assembly tools, predominantly the welding tools in this aspect, as well as the bolt creation tools for chassis and powertrain components. We have automated several of those. Those comes in real handy to help you build one of the best and fastest finite element models that you can have. And then again, we have the CAE parameterization coming in. The models that you mesh in MeshWorks are parametric, so that way you could have your DOE optimization at any stage. And further in verification and validation stage 2, several of our bulkhead creators, part extension, part contractors, bead creators. So there are several tools which come in handy, which will help us to fine tune our design performance at local locations, as well as even we can look at welding as a parameter and study the welding as well. And in the maintenance phases, one of the good part is MeshWorks enables you to create design changes without waiting for CAD. So as we explore several value engineering ideas, MeshWorks helps you to implement them on the CAE model. And if you find it successful, then you can implement it on the CAD. So MeshWorks module cover nicely all the activities that you have right from the concept stage until the VAVE stage of the product development cycle. So as we go into the next slide, it gives you a brief idea of how MeshWorks 2020 toolset, what we discussed in the penultimate slide, how it lines up for the farm equipment in general. So we are going to see in demonstration today, application of each of these bubbles that you see in the picture, where we are going to see how upfront in the concept stage, how MeshWorks is going to help you from the morphing standpoint, as well as concept works standpoint. How is it going to help to quickly create workable concepts, and how you can create family of new models, or how you want to really create a new design very quickly for our ergonomic studies, manufacturing feasibility studies, costing estimate, blank sizing. There are several of the work that we are pushing upfront in the concept stage, and MeshWorks is morphing will really be a great benefit, and it right away works on the CAD data that is already available with you. So you're going to see that as a demonstration. Further to that, we are going to also see pre-processing demonstration focused on several kinds of weldings and how we do it and what benefit it adds up to your process. And we are also going to see, as part of CAE parameterization, how we are able to do changes to the design on the FE model live without waiting for CAD. So in a nutshell, you're going to see several things as to how MeshWorks really plays the role in the product development cycle as far as the farm and construction equipment industry is concerned. So my colleague Abdul, as he takes over the stage, this is what he's going to present to you today. He's going to look at concept modeler from MeshWorks and show you how it really helps you to create workable finite element models from your generative design or topology output. And then we're going to see CAD morphing, how it comes up front and helps you create new structure models, CAD models that you can very nicely use for packaging and other manufacturing feasibility estimations. We are also going to see, once the CAD is all done, how MeshWorks tool comes in handy to create mesh models, assemble them, get them ready to run. And finally, we are going to see how MeshWorks can be used to make changes on the finite element model without waiting for CAD. So these are all the 4 different aspects we wanted to position before you and see to make sure that it brings in the acceleration that you really need in your activities. With that having said, I would hand over the stage to Abdul, and he would walk you through live and demonstrate to you each of the tools and show you the value that it brings to you. Thank you so much. Over to Abdul.
Yeah, thank you, Karthik. It was a very nice introduction. So am I audible to you, right? Can you confirm, Karthik?
You're audible. You are audible,
Yeah,
certainly,
okay.
yes.
Yeah. Good morning and greetings, everyone. So today we are going to see the live demonstration of some of the premium like a tool set of for which is like very relevant to farm and equipments kind of approach. So what you're seeing in the display is one of the model which is like we took a tractor hook for a material handling equipment. So how quickly we can build a structural validation mesh on a topology optimization output. So that is what we are going to see here. So as Karthik rightly mentioned before, like we already have a set of ConceptWorks tools. So where the CAD does not play there, like instead of CAD, like we can play on the mesh level itself. So so that is one thing, like where we can generate the entire model. So from nowhere to complete mesh model without a CAD's help. So here, like we have a concept modeler for the casting especially. So this is for the casting. So this is our ConceptWorks casting tool. So so this is an input of topology optimization outputs of 2 ends, which is having to be connected to farm equipment and the pulling so pulling assembly. So here this complete hook has been run through a topology optimization in a product development cycle. Then we got the output of the topology optimization. So where we need to add the material and where we need to remove the material. So here we used our ConceptWorks to generate this entire member, and also how we are connecting it and how we are removing and adding the material into it. So this is what we are going to see in this demo. So I'll right away move into the demo. So as you can see here, so this is the model, so which is like so came as an input. So in this input, like with curves and points as an input, we will generate the planes. So with these planes, we are going to extract the cross-sectional identities. So which is like, it may be rectangular or square or I-section or anything. So we are just going to generate it, and we are going to create that entire member there. So based on the topology optimization output, then we are going to join the ends to an extent. So how we are going to join is like we have our own like selecting the face here. So we are going to select the face of the 3D component. So it is all 3D component only, it is not a 2D. So where we are going to extract the cross section. So this cross section is going to have some set of points, so which is a source and which is a target. So we are going to match the source and target with the points. So creating a points and splitting the lines, which is we are making sure like it is going to have like a equal count of cross sectional curves. So at last we are going to select the curves like a source and target kind of approach. Then it is going to nicely connect those two members, like the member and also the link region. So it is going to create and connect it. So it is all a tetra component, and tetra has been created, and also along with the quality it will be taken care in the background. So not only like only the face, we can take it along with the face, we can take with the curves also. So the user can define the curve here, so on his preference, and then so that particular curve also he can do the splittings based on the cross section of the source. So how many splits we have, the same similar splits we are going to make it on the target as well. And then the user is going to provide the source and target again, and it is going to be connected as well. So this is a very quick and efficient way to create outputs from a topology optimization. So which is our tool set, which is very thankful for us to that tool, which is our ConceptWorks casting. So here, uh, so after creating this entire member, so how we are going to remove or add the material into it. So that is one again a challenging part. So where we are going to just sketch the cross section there and to remove the material there. So we, with the reference of topology output, like we can just draw a curve and we can remove the material, and wherever you wanted to strengthen the region, so in that part, like you can add the materials as like we have our standalone tools, which is a rib creation tool, which is also included into the ConceptWorks itself, the casting itself. So these tools all been like already been there in as an individual tools, but all put together we have combined it to create an nice very nice output of a topology optimization result. So which is called our ConceptWorks casting, so which is very relevant to our farm equipment kind of section for the product development cycle. So initial product development cycle, the one can build this entire model using this kind of approach. So moving on to the next demo, so we are having our CAD morphing, so where we can do any changes in the earlier stage itself before generating the mesh. So if at all the user is having the existing CAD data, which is a very old data, so and so it is on cabin, so which you are seeing it here, and we are having something new cabin structure, so which you wanted to make it something new. So with in the earlier stage itself, without doing any meshing or validating, one can do the morphing in the CAD level itself. So you should have been seen already in the past like webinars with the mesh morphing in the meshworks, but this is like our CAD morphing, where you can do the morphing in the CAD itself directly. So I'll just directly go to the demo. I'll just open up the window. So this is the model which you've seen in the presentation. So it is a cabin model. So it is a completely a CAD model. So how we are going to do some changes. So we already created some parameters into it. So I'm just quickly going to show the parameters. So what all the parameters we have created in this particular model. So we took the reference of the presentation image, so which we got it. Just give me a minute. Yeah. So I'll just go and review the parameter. So first parameter would be my length parameter. So I wanted to increase the overall length of the cabin. So I have created this particular parameter. So I will just take it into a closer look. So you can see the original position and the deformed position here. So we are changing the complete length of this particular model without changing any dimensions of the window structures. So this is one of the criteria which we got it as an input, which is like we no need to change the windows regions, like the glass sealed parts regions. So which is like manufacturability. So based on considering the manufacturability and like after like for going for the protection, so how it is going to be. So we are considering those as a sector, and then we are going to do this morphing. So I'll just go to the other parameter, so which is a window parameter. So if you see in that image of the component, like you will be having an oval shaped design structure. So we wanted to mimic the same as here in this cabin as well. So where without changing any dimensions of the window region, we are just adding in a parameter which is like giving the structural shape, which is including like considering the space inside for the tools carrying region. Like so we can carry more tools into it in the background, and we can have a sitting region also. So considering those in a nutshell, like we are creating this parameter. So the next parameter would be my window parameter. So here, like I'm going to just change the entire window section. So this is also like, so we are having a feasibility to change the window section, but not the like the size of the window. So which is a constraint for us. So these are the parameters which is created very quickly in like CAD morphing. So which is like directly we are implementing into the CAD itself. So for this is very useful for the early stage conceptual design changes. So I'll just move on to the next demo. So for the next demo, it would be like our meshing for the farm equipments. So we wanted to showcase you like we already been seeing the tetra meshing and hexa meshing in the webinar. So this is our sheet metal meshing. So how we are going to handle the sheet metal meshing as well as automated building, connector creation, all those in a single demo. So this is one of the construction of a crawling component assembly. So where so this entire assembly would have been having thousands of components. So which we wanted to mesh it, and we wanted to create the seam wells there and connect the parts together. So this is an like entire workflow which is like we followed for that component of assembly. So I'm just showing into a set of 300 components here. So here I'm just going to give the input as like the CAD models for the meshing. So the input will be having the CAD curves also, like which is a weld lines as a inputs also we got it. So which is an added hand for us. So here we selecting the entire component and we are going to give the templates. So this mesh template is going to have all the informations of meshing, like what is the element size, what is the washers needs to be captured, like what are the diameters of the washers it need to be captured, and what is the fillets radius which need to capture, and how many layers of the fillets which need to capture. So all the information are going to be there in this particular template itself. And even like we are going to capture some of the irregular holes like slots also in this meshing itself. So I'm just right away going to show like we are going to say execute. So the mesh is going to get generated in all the components. So midplane meshing. So along with the thickness, it is going to get assigned. And also the quality is going to get cleared in the meshing level itself. So as you can see, the fillets, like the holes, all has very perfectly. And after doing and we got the output, we have the CAD curves as an input now for the welding purpose. So with all the CAD curves as a welding line, we can just generate auto create connectors into MeshWorks itself. So where it nicely identifies which is your master and which is your slave, and it will generate the weld curve something like this. So this is your weld curves. So with this weld curves, one can do select that weld curves and just say execute. It is going to nicely connect up with the master and slave component exactly with the quad welding approach. So these are the welds which is generated with auto execute. So even though it is like a parallelly placed component or a perpendicularly placed component, like it is going to connect it very nicely. So as you can see it here, like we have like multiple types of weld, like how we going to create and how we can parameterize the weld, that you are going to see in the couple of slides later. So after this, I'm going to the next demo, so which is our design enablers changes. So once after meshing in MeshWorks, like our entire mesh getting parametric, we can do any changes like rib thickness, wall thickness, or tube diameter change, or fillet radius change. Any changes we can do it in the mesh model itself. So which is like we are giving an added hand to the user to do it in the early stage itself for the analysis purpose. And also for adding the ribs. And then so if the model is being meshed and it is not yet connected, so we can have entire seam welding approach of library of approach to do the seam welding, so which is can be parametric also. So and also we can just do any stiffness improvements also, so like increasing the fillet radius change, or any adding the ribs also in the sectionals to increase the stiffness. So that is also possible. So I'm just going to the demo. So this is our tetrib creation tool. So where we are going to see so which is our hotspot region. We wanted to create any cross rib over there. So in the tetra component itself. So we are just going to give the tool input as just the planes. So I'm just going to create a plane over there. So this is like an entire workflow of a tool for rib creation purpose. So it is going to nicely ask for the reference points like a starting and end point. So after providing the endpoint, it is going to provide you the cross-sectional view to create the ribs cross-section. So you can sketch the rib and you can just modify the ribs using the intermediate points. So it is all user controlled and interventions. Like so after creating it, like you can just have the cross section of the 1Ds, and then you are going to get the 2D as a like a reference, and then it is going to nicely create a rib over it in the solid itself. So considering the similar fillet regions, how it is captured in the other ribs. So it is going to create a rib in like no time. So this is our tetrib creation tool. So which is like entirely handled over into the tetra itself. We don't need to take any phases and work on it like a lot of time to spend on it. So then it is like our casting and sheet metal component parameterization. So here, as I told, like it is completely parametric when it is going to be meshed in MeshWorks. So we can do any quick changes like shape changes on a casting component like based on the load cases. And then as you're seeing in the right, you can do any fillet radius change to increase the stiffnesses. And if at all you wanted to change any wall thickness on the model, so you can do that immediately by selecting the two faces. So this is also like a very quick way and efficient way of doing the morphing in MeshWorks. So moving on to the next slide, so which is our seam welds. So after doing the meshing, so how we are going to do the welding. So what are the types of welding we have? So that is also I'm going to show it to you here. So it is one of the fabricated structure component. So where we have entire sheet metal assembly. So for the two sheet metal components, so how we are going to do the welding. So we can just select the master and slave. So with a 1D element as an input, so it is going to generate nicely a weldment so in between the two components. So this is one of the type which is RB2 type of weldments. So then it's a seam beam type of weldment we have. Then the another type is the quad weldment. So then it is going to have the quad weldment along with the heat affected zones. So then we have another which is angled weldment. So we can control the angle over it. So angled weldment along with the heat affected zones. So here the mesh itself will get remeshed based on the welding. So it is one of the type which is RSM weld. So after doing the weld, so how the weldment can be parametric in MeshWorks. So everything can be parametric. So how the weldments are getting parameterized. So this is one of the parameter. So we can do the weld length contraction. Like so the entire weld length can be contracted or expanded immediately. So based on the extraction and contraction, like it is going to be like our model going to be get remeshed and it is going to be stitched together. So the user doesn't need to spend any time on doing this, reducing the element size, and then you're going to do any remesh work on any backend work. You don't need to do it. And also we can just provide number of wells as a parameter, like how many well the elements can be there. So as a parameter also we can provide. So this is also one of the parameter, so which you are seeing in the display. And this can be applicable for either any type of welds, like quad weld or V quad weld. So all these can be applicable into this parametric weld approach. So moving on to the next. So as you see now, like which is a 2D weldment and the 1D weldment. So here it is one of the farm equipment component, like which we are going to showcase you how the 3D. The user is going to select the path of the weldment and going to generate a 1D, and he is going to select that 1D as an input and source and target like a slave or master component for the weldment. So in this case, it is going to be hexa and a hexa component, and it is a tetra weldment. So this tetra weldment can be like any shapes we can change it, which is flat, concave, convex, or both like a hybrid weld also we can create it. So now we are seeing a concave weldment. So now it is like a convex weld. So where we can provide the angle to it. So then you can just merge both of the convex and concave both in the same weldment. So which you can provide as a starting and end point. And how this weldment is completely merging into the master and slave component. We have multiple number of connecting types, which is like with the HAZ layers creation. So the tool itself nicely stitches and connects with the HAZ layer with the 2 layers of in the border. And the user can generate that entire mesh into completely a quad mesh also. So instead of tria. So one is merged with contact. So the tool will nicely merge this entire nodes into the master and slave, and then it is also will be creating the tie contact between the two. And if at all the user wants no need of any merge node to be there, and only the contacts needs to be there, so that is also possible as another option into a weldment region. So where we can just non-aligned coincidence nodes, like we can just give as a non-aligned, and the contact will be created as tie contact. So this is also one more option which will the tool itself will provide. So this also has been said, like this entire weldment can be a parametric weldment. So the length of the weldment can be changed, the height of the weldment can be changed. So all this like entire 3D weldment can be a parametric model. So here we wanted to show you like how much scenarios we are handling into the weldments. So which is the seam weld scenarios for the tetra to tetra component with the tetra weldment, and tetra to tetra component with the hexa weldment. So similar to that, so how much type of weldment we can have into it, which is a hybrid type of weldment. And also with the heat affected zone weldments with a set of element sets and node sets attached to it. So that is also one of the criteria which we have it. So tetra HAZ layer creations. So these are the seam weld scenarios which we have it right now. And overall, like so this is the workflow which we saw in the the entire demo purpose in the product development cycle. So which is like from the topology optimization output, how we generated the mesh from like a node CAD region, then how we morphed the CAD morphing, so entire cabin into a CAD morphing, and then meshing and welding process, and then how we improve the structural region with the tetra rib creation and the fillet region. So the entire MeshWorks 2020 takeaway messages, like I will just hand over the stage to Karthik back. So over to you, Karthik.
Thank you so much, Abdul, for your demonstration. I think that quite nicely captured how MeshWorks as an engineering platform addresses the need as engineers we face when we handle farm equipment and construction equipment side of the work, how we can really use MeshWorks tool set, be it CAD morphing or be it realizing a valid structural configuration from a generative design or a topology based output. You have seen that how the concept modeler and CAD morphing portion of the tool set really help you there. This is a very important first step. And once we leverage the benefit of MeshWorks from those tool sets and assume that we have the complete CAD data ready, then the MeshWorks' mesh modeling and welding tools comes in handy. We are able to create very high quality mesh models and welding, and also both the meshes and welding are parametric, by the way, so that gives you an additional freedom. And also my colleague Abdul pointed you today that the welding is not a standard simple type of welding. Comprehensive ways to represent seam model, seam welding is already addressed in our MeshWorks. So that way MeshWorks takes care of starting from a CAD data, the preparation of a solver ready model, meshing, connections, contacts, all of it can be carried out in MeshWorks for your Simulia interface or ANSYS interface or Nastran interface. Solver can be anything, the state-of-the-art solvers that you use. MeshWorks has interface with all of them. And as we have the baseline results available from our simulation, now is the time when we need to look at either mass saving options or the mass optimization options or performance optimization options. That is where the making design changes on the mesh itself without CAD comes in handy. And in addition to that, we are able to make the CAE model parametric. Maybe it is the wall thickness changes or the number of tetra ribs in the powertrain or a driveline components, or it is the seam weld length in the axle driveline kind of components, or maybe it is the wall thickness changes as we talked about in the transmission housings or the auxiliary gearboxes of our farm equipment. Or it may even, as we go up to the chassis where we are using several thick sheet metal parts, we can sort of use MeshWorks to balance and arrive at rationalizing the steel procurement in terms of should I procure more 8 mm and 12 mm than 16 mm. So we can do all of those trade-off studies using the parameterization of model in MeshWorks. So the design enabler tools, parameterization tools help you move towards optimization in a structured and a phased and a faster way, and that is an additional benefit that we bring from MeshWorks. As you look at it in a holistic scenario, MeshWorks as an engineering platform helps you at each and every stage of your product development as we progress from our farm equipments. It can be the driveline components or the powertrain components, chassis components or the cabin components, or even some of the components associated with implements, basically the rotavators or any kind of implements. So the tool sets are pretty comprehensive enough and generic enough, and they can be applied across the board. So this is the message that we wanted to provide to you through this set of demonstration and through this webinar. We would request your feedback, questions, if any. Thank you so much for taking your time and joining in. And we can readily certainly take up some questions if there are any. We'll be more than happy to answer them. We'll also be able to demonstrate specifically to your group or your needs in a much more detailed manner on any of these aspects. Now the floor is open for questions.